last 12. Number 1. All of the things in group A are blugs. None of the things in group B are blugs. Which two things in group C are blugs? Has something to do with lines, curved or straight. All of the things in group A are blugs. None of the things in group B are blugs. Which two things in group C are blugs? Questions 2 through 4, right here. Number 2, the number of faces a prism has always equal the number of sides the naming face has. Is that plus 2, plus 5, times 3, plus 1, or times 2? In other words, if we had a prism, this being a rectangular prism, so our face would be this right here, or our base, I mean, would be this. So we would have 4 sides on our base, which means this is 4 sides plus what? How many faces would this have? So we would have 1 face on top, a face on bottom, 1 on each side, and 1 on front and back. So how many total faces did I have? And then add that number together and you would have your answer. So question 2 again, the number of faces a prism has always equals the number of sides the naming face has, or the base plus how many? Or times, I guess, but it is plus. Number 3, the number of edges a prism has always equal the number of sides the naming face has. The number of edges a prism has always equal the number of sides the naming face has. And this is a times one, so hopefully that gives it away. So in other words, our edges are the straight lines that hold them together. So this one has 1, 2, 3, 4 on the face, on one face or the base. But then you'd have 5, 6, 7, 8, 9, 10. You got to figure out what did I times by to get that total number. The number of edges on a prism has always equals, the number of edges a prism has always equal the number of sides the naming face has times what? And number 4, the number of corners, so the points or vertices, a prism has always equals the number of sides the naming face has times what? Number 4 again, the number of corners or vertices, so those corners on the shape, a prism has always equals the number of sides the naming face has times what? The next 7 questions are about the cake on your sheet. Please realize that this one right here that's smooth, that very first piece, is the only piece that has frosting on it. Question 5. Bruce wants to eat the piece of cake with frosting on it. What fraction of the cake does he want to eat? Question 5. Bruce wants to eat the piece of cake with frosting on it. What fraction of the cake does he want to eat? Question 6. Before he can do this, Allison comes along and cuts the cake into smaller equal-sized pieces by cutting from A to B, C to D, E to F, G to H. Draw the lines to show what happens. What do we call the fraction Bruce eats when the cake is cut this way? So once you've cut the cake, and don't simplify or you'll end up with your original answer. So once he cuts the cake, what fraction of the cake will he eat now if he wants to eat this piece that has frosting on it? Number 7. Allison eats 13 of the newly cut pieces without frosting. What fraction does she eat? Allison eats 13 of the newly cut pieces without frosting. What fraction does she eat? Number 8. What fraction do Bruce and Allison eat all together? What fraction do Bruce and Allison eat all together? Number 9. What fraction does Bruce eat as a decimal? What fraction does Bruce eat as a decimal? And question 10, what fraction does Allison eat as a decimal? What fraction does Allison eat as a decimal? Number 11, write the fraction they eat all together as a decimal. Write the fraction they eat all together as a decimal. Number 12, one member of the group listed on your sheet is different from all the others. Write the odd one out on the answer line. One of the members of the group listed on your sheet is different from all the others. Write the odd one out on the answer line. Number 13. We did one like this last week. Number 13. Which face is missing from X? Which face, A, B, C, or D, is missing from X? Number 14. Which face is missing from Y? Which face is missing from Y? Number 15. Which face is missing from Z? Which face is missing from Z? Number 16. Harry has a mass of 98 kilograms. He guzzles a liter of water, gets on the bathroom scale. What should his mass be now? Harry has a mass of 98 kilograms. He guzzles down a liter of water, gets on the bathroom scale. What should his new mass be? So look up 1 liter of water is equal to how many kilograms? So look up, Google it, whatever. 1 liter is equal to how many kilograms? Question 16 one more time. Harry has a mass or a weight of 98 kilograms. He guzzles down a liter of water, gets on the bathroom scale. What should his mass or his weight be now? Question 17. Which statement for question 17 is correct? R, S, T. Which statement for question 17 is correct? R, S, or T? The last 3 questions are about the problem on your sheet. We spend approximately 1/3 of our lives asleep. About how many hours of every day is this? Question number 18. What is this problem asking us to find? Is it asking us to find A, what fraction of our lives do we spend sleeping? B, how many hours in 1/3 of a day? C, how many years do we spend sleeping? Is it asking A, what fraction of our lives do we spend sleeping? B, how many hours in 1/3 of a day? C, how many years do we spend sleeping? Number 19. The next step in problem solving is to ask, how can I find the answer? Which operation symbol or symbols would you use to find the answer to this product? Which operation symbol or symbols would you use to answer this problem? Question 20, find the answer and put it on your answer line. You have 2 activity questions down here, questions A and B. It says, does 1 whole orange equal 4 quarters? Meaning if you cut along those lines, would 1 whole orange equal 4 quarters? It says, now join the dots in the second and third oranges. How many quarters are there in 3 whole oranges? All right.